So alternative to the arrow algorithm is the LCD, which is probably the more common one. LCD stands for lowest common denominator. In other words, we have these two numbers in the denominator. We want to find the smallest number that they go into. Now we've done that before. That's also called the lowest common multiple, but it's of the denominators. So the lowest common denominator is just the lowest common multiple of the denominators. And we learned a few different ways to find a lowest common multiple. My favorite way is to use the prime factorization method. So I'm going to take my 22 and say, well, 2 goes into 22 11 times. And then the 6, 2 goes into 6 3 times. So the lowest common multiple of those two, starting with 22, 22 says you have to have a 2, you have to have an 11. 6 says you have to have a 2, but I already got that covered. So 6 needs a 3. So you take as few factors as possible without any replication. So I don't need another 2. So the LCM here is going to be 2 times 11 times 3, or you could say 2 times 3 times 11, which is 66, should be the smallest possible denominator that you can have with these two. Once you find that, then you have to identify the missing factor. So 22 goes into 66 how many times? Well, 22 goes into 66 3 times. And 6 goes into 66 11 times. So once you have the prime factorizations and the LCM, you can get this other information. Why do we need that? Well, we want to take that 7 over 22 and the 1 over 6, and we want to rewrite that as some amount out of 66 plus some other amount out of 66. And to get from 22 to 66, I now know that I have to multiply top and bottom by 3. So I go 3 times there and 3 times there. 3 times 22 is that 66 I have here. 3 times 7 gives me 21. 6 goes into 66 11 times. So multiplying this by, oops, not 6, but 11, top and bottom. 11 times 6 is that 66 down here. 1 times 11 is 11. Adding those up, what do I get? Well, 21 plus 11 is 32. Guess what? Even though I found the lowest possible denominator to use, I still have to reduce. So 2 goes into 32, 2 goes into 62. Let's see, 2 goes into 32 16 times. 2 goes into 66 33 times. So I get the same answer I eventually found above, 16 over 33. All right, so pros and cons here. This is the arrow algorithm up here. This is the LCD algorithm. I have to do the prime factorization, then I have to put the prime factors in the correct order so I get the smallest common denominator, and then I have to figure out how many times each of the original numbers went into 66 so I can figure out how to adjust those fractions and get the new fractions. And still, sometimes I have to reduce. Not all the time, but sometimes. With the arrow algorithm, I didn't find the lowest denominator, but it was pretty quick. I just had to multiply 22 times 6 to get 132. Then I had to multiply the 6 times the 7 to get 42, 22 times 1 to get 22, 42 plus 22 is 64, and bang, I got an answer fast. It took me a lot more work over here to come up with an answer up front. So LCD algorithm is a lot of upfront work, here, here to there. Arrow algorithm is really quick, but I had one extra reducing step. What's easier in your mind? We're all different, reducing or finding a lowest common multiple and adjusting denominators. my work in math with adults and kids is that people reduce easier. They find that easier to do than this work of the lowest common multiple and adjusting the fractions. But again, we're all different. There's some people who find this easier. I'm not saying the arrow algorithm is necessarily better. It's just different. But my point here is, even if you find the lowest possible denominator, you still have to reduce sometimes. Sometimes the arrow algorithm and the LCD algorithm agree on what the answer is up front. So for example, slightly different set of numbers. Suppose we had just something simpler like 2/5 plus 1/3. And if I add these two together with the arrow algorithm, 3 times 5 is 15, 5 times 1 is 5, 3 times 2 is 6, 6 plus 5 is 11, and then it must be 15ths. If I use the LCD algorithm for 2/5 plus 1/3, 5 happens to only factor as 1 times 5, 3 happens to only factor as 1 times 3, so the LCM of those two happens to be 3 times 5 or 15. Okay. So if sometimes, again, they will agree. And so, oops, sorry, I'm doing the arrow algorithm. So then with the LCD algorithm, I would say, oh, well, I just have to multiply this by 3/3 and this by 5/5. And so now I have 6/15, there we go, plus 5/15 for a total of 11/15. Okay. Not quite as much work because the factoring there wasn't much to do for factoring. So here, again, they led to the same answer right away. So sometimes they will agree right away on the answer. They'll always agree after reducing on what the right answer is because they both had fractions correctly. It just happens to be more than one way to do it.